Here, let us discuss about support vector machine. So, as we all know, with classification, you can predict categories, while in regression, you generally predict values. In supervised learning, classification is a multi-dimensional. So, it's usually multi-dimensional. That means sometimes you only have two classes, yes or no, true or false, like that. But sometimes you may have more than two. So if you take examples like risk management or risk modeling, then you can have low risk, medium risk, or high risk. So SVM is a binary classifier. So classifier which is used for those true or false, yes or no type of classification problems. So here features are important in supervised learning. So if there are several features, SVM, it can classify them, or it may SVM can be considered as a better classification algorithm choice as opposed to logistic regression. Under supervised learning, you present the computer with example inputs and their desired outputs, right? So what is the goal of SVM? The goal is to learn a general rule that maps the input to those outputs. So if you take examples like bug detection, customer churn, stock price prediction, or weather prediction. So weather is sunny or not, or it is rainy or not rainy. So all of them are considered as examples for SVM. So classification algorithms. So how they'll make predictions? So first they'll take the past data. So here the data is nothing but the data for which you know the outcomes. And after that, it will train the model. So it will take the past data, then train the model, and after training, it will test with the new data. So that after that, it will check, it will make predictions in order to check, say, suppose the given images are truck, so we gave some vehicle images. Then after training, we need to check whether the given vehicle is a truck or a car. So similarly, if you take this example, here you can see dataset contain collection of vegetables as well as groceries. So by using this classification model, we can identify them into two different, or we can classify them into two different categories. One is vegetables and second one is groceries. So SVM, it's a type of classification algorithm which mainly classifies data based on its features. So SVM will classify any new element into one of the two classes. If you see this, so SVM, it's a new type of classification algorithm, so which is based on features, right? So if you take this, here we are having input. Okay, so this machine, it should segregate and classify this data, and the output should contain two classes. So class of apples and oranges. So we are segregating the data. So once you give it some inputs, here the algorithm, it will segregate and classify the data and then create the outputs. So when you ingest more new data, like some unknown fruit, so after this is a training part, after training, if you give some unknown fruit variable, this algorithm, it should predict or it should classify the fruit here. So it should identify whether the given fruit is apple or orange. So here, how does this SVM work? So here, let us take one example. So just pretend you own a farm and you have a problem. So problem is you need to set up a fence. So your farm is having rabbits and wolves. So in order to protect rabbits from wolves, you need to set up a fence here. So where do you build your fence? So that's a problem. So one way to get around the problem is here you need to build a classifier based on position of the rabbits and wolves in your pasture. So if I do something like that, and if I draw a decision boundary, so these are set of rabbits and wolves. Now, in order to create a fence, so here I'll draw a decision boundary between these rabbits and wolves. And after that, it looks something like this, right? So here we are drawing a decision boundary for separating these two classes. So this is exactly how SVM works. So it draws a decision boundary, which is nothing but the hyperplane between these two classes in order to separate them or classify them. Now, so how do you know where to draw a hyperplane? So the basic principle behind SVM is to draw a hyperplane that best separates the two classes. So hyperplane should always separate the two classes in an efficient way. So in our case, what are the two classes? One is rabbit and second one is wolves, right? Yes. So what is support vector in SVM? So here, let us draw a random hyperplane, and this is a random hyperplane. And you can check the distance between the hyperplane and the closest data points from the each class. So here you can see this is the closest data point from the hyperplane, whereas from this class, this is the closest data point. These closest data points to the hyperplane are called as support vectors. So what we are calling them, so these two data points are known as support vectors. So the hyperplane, so that's the reason why we are naming this as support vector machine. So hyperplane is drawn based on the support vectors, and an optimal hyperplane will have maximum distance from each of the support vectors. So this distance between the hyperplane and the support vectors, this distance between the hyperplane and these support vectors, we call that as margin. So here SVM is used to classify data by using a hyperplane such that distance between the hyperplane and support vectors is maximum. Say, let us try to solve this problem. Suppose here, if I give new data point and now I want to draw a hyperplane which best separates the two classes. So earlier we already separated the classes and now I have one new data point. So the one which is represented in blue color. So now I need to classify whether I need to check whether it falls under this category or this category. So I need to draw a hyperplane which best separates these two classes. So let us start by drawing a hyperplane, and after that check distance between the hyperplane and support vectors. So let us draw like this. So we are drawing a hyperplane, right? And now you need to check the distance between the hyperplane and support vectors. So this distance, you need to calculate it. So here I'm trying to check if the margin is maximum for this hyperplane or not. So this is one possibility. So second possibility, if I draw a hyperplane, something like this. So this is a hyperplane, second possibility. So here you can observe that the margin for this hyperplane is more than the previous one, right? So this margin is more than the previous one. This one. It is very clear, right? So this can be considered as an optimal hyperplane. So, okay, till now it's clear. Say suppose our data, so here our data is linearly separable. So that means we are able to separate the two classes just by drawing a straight line. Say suppose if our data is something like this. So here we can't draw a hyperplane which separates the two classes. So even though if you draw, it looks something like this. So this is not the proper way of classifying two classes, because here also we are having collection of two categories, and here also we are having two kinds of classes. So this is not the best way, right? So this is where we need to use nonlinear SVM. So nonlinear SVM. Here kernel functions, they offer the user the option of transforming nonlinear spaces into linear ones. So until this point, we were plotting our data on two-dimensional space. So we had only two variables, x and y. So simple trick would be transforming the two variables x and y into a new feature space involving a new variable z. So along with x and y, here we are taking one more variable, that is z. And we are visualizing the data on a three-dimensional space. Here you can see the image. So we are having variables x, y and z. Earlier we have only two variables x and y. So when you transform this two-dimensional space into three-dimensional space, you can see that there is a dividing margin between two classes. So here these two classes are separated. And now you can separate the two classes by drawing the best hyperplane between them. So you can classify them by drawing a hyperplane something like this. So this is how we can classify the classes. Considering if you consider real world applications of SVM, then some of the important applications are, so you can use it in different areas of daily life like face detection. So where using image training data, SVM classifies pixels in images like a face or whether it is a face or not a face. And you can use it in text classification. So where the training data is used to categorize different types of documents, whether the document is a news article. So if it is a news article, then that can be categorized or classified into business news or entertainment news. Similarly, it can be used for classifying images also. So by classifying images with improved techniques, SVM increases search accuracy. And even in bioinformatics, so SVM algorithms, they have increased the effectiveness in protein homology detection or cancer classification, gene classification. So like that, it is used in various applications.